Hi, Calculus class. We are working on the 2009 question number 5 question. It is a region R question. And let's jump right into it. They give us a graph. They give us two equations. It's not calculator, so no calculator. And part A says find the area of region R. Well, the area of any region is just the integral, and then it's the top equation minus the bottom equation. And so that's the general setup, area of a region, top minus bottom, and you just integrate it. But here's the thing. You need to know which equation is on top and which is on bottom. And in this particular question, they gave you the equations. They didn't tell you which was on top or bottom. So the big key to this is just having a basic understanding, because you don't have a graphing calculator, of what things look like. So the big key here is this right here, this x minus 1 squared. It's the biggest exponent. It's an x squared graph. It tells you it's a parabola. And because there's a negative that will eventually be in front of this x squared, it's a parabola facing down. So that tells you that's this one up here. Okay, so this whole equation is h of x, and then that means this equation here is g of x. And it should make sense. Sine and cosine kind of go like this, and you can kind of already see and feel the flow a little bit. So when it's top minus bottom, it's h of x minus g of x. But since I have to take the antiderivative of this, I'm going to go ahead and just write it out. So, again, it's from where to where. So we're integrating. It's going from 0 to 2. And then it's going to be top equation minus bottom. So my top equation, as I mentioned, was h of x. So my top equation is 6 minus 2, x minus 1 squared, minus, and then my bottom equation, which I'm going to keep in parentheses. Negative 2 plus 3 cosine pi over 2x. Alright, and that's a lot of stuff to have to write down. But that's my setup, and it's worth 1 point. Then they give you a point. You will eventually get another point for taking the antiderivative of this piece, and then taking the antiderivative of everything else, and then the fourth point for plugging in the top and bottom and subtracting. Okay, so let's just go ahead and start with the antiderivatives, okay? And we're actually just going to leave everything as is. So, the antiderivative of 6 is 6x. Now, what about this antiderivative here? So I'm just going to show you off to the side really quick. So if someone wanted to know what's the antiderivative of negative 2x minus 1 squared, I would just think, hey, what if this was u substitution? What if the u is x minus 1? Well, if the x minus 1 is my du would be 1 dx. And I already have a 1 dx. So this is basically like negative 2, that's a u squared. Because my dx is my du is 1 dx, I don't have to put anything or offset it. And so the antiderivative will simply add 1 to the exponent and then multiply by the reciprocal. So that's going to be the antiderivative of this piece. So it's negative 2/3 u, and I'm going to replace the u to the third power. Again, because the u is this, the du is 1, I'm just adding 1 to the exponent and multiplying by the reciprocal. Alright, I'm going to continue here. So with the next portion, again, I could distribute and make everything nice, but I'm not going to. I'm just going to keep the minus sign here, and we'll just keep everything where it is. The antiderivative of negative 2 is negative 2x, and then we're going to take the antiderivative of this piece. Okay, now I'm going to work this off to the side as well. The first key to getting this part is to remember the antiderivative of cosine u du is sine u plus c. Well, we're obviously no plus c's here. But anyways, so if I want to take the antiderivative of 3 cosine pi over 2x dx, the first thing I would do is u substitution, because I need this to be a cosine u. So if my u is pi over 2x, my du should just be pi over 2. Now if I want my du to be pi over 2, first of all, this 3 is not what I want, so I'd have to take the 3, slide it to the outside. It's part A if you're fast forwarding, sorry, okay. And then I need a pi over 2, and I can put a pi over 2 as long as I offset it with 2 over pi. So once I've done this, this is now 6 over pi. And then everything's in the right spot. That's cosine u. The pi over 2 dx is the du, so it just is now sine u. And again, my u is pi over 2x. And that's what's going to go here. So 6 over pi sine pi over 2x. Okay, now my final answer is going to be an absolute mess if I let it become a mess, but we'll go ahead and see what happens. So now we plug in a 2 and a 0 and subtract. So I'm going to plug a 2 in for everything. So I'm going to put a 2 in here. I'm going to make this a little bit tinier. So a 2 goes here. A 2 goes here. A 2 goes here. And a 2 is going to go here. Now when I put a 2 here, this 2 cancels out that 2, and it's actually just going to leave me with pi minus, and now I'm going to replace everything with 0. Okay, now when I do this, I'm just going to put the zeros there, okay? I'm concerned, I'm worried, I don't want to be worried. So I'm going to put a 0 here. Yes, it's 0, but this one's not going to be 0, and I'm not going to simplify things, so I'm just going to plug it in. So 2/3, 0 minus 1 to the 3rd. Now we move on, so now it's minus. I'm off the screen. I'm just finishing plugging it in. Here's the last part. When I go to plug so I plugged a 0 in everywhere. When I go to plug a 0 in here, pi over 2 times 0 is 0. So this is sine of 0. Okay, now this is your final answer, but you can't say earn it on this one. There is one extra rule. The only thing you can't leave in earn it questions is this. So we actually need to know what those are. So if you quickly go ahead and look at the unit circle here, here's 0, here's pi over 2, here's pi, and I look at the ordered pair. So here the ordered pair is 1, 0, and here the ordered pair is 0. Wow. Sorry, this one was 0, 1, but we don't need that one. So this is negative 1, 0, and remember it's cosine and sine. So sine of pi is 0, and again this is cosine and sine. So sine, almost fell, sine of 0 is 0. So both of these are 0. Instead of rewriting all this, which I do not have in my capability right now, I'm just going to get rid of sine of pi and make it a giant 0. And over here, I'm going to get rid of sine of 0 and also make it a 0. And there's no way in the world I'm simplifying this. Could I? Yes. Am I? No. And that's it. Part A is done. Okay, now let's go look at part B. So when I go to look at part B, they say region R is the base for a solid. For the solid at each x, the cross-section perpendicular to the x-axis has an area of blah, 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 blah. So when we start talking about cross-sections, that's where we normally take a nice little cross-section here, and we either build out squares or semicircles. That's not happening here, but in case it shows up later on, if the cross-sections were squares, you would say, if it's a square, if this is S, then this is S, and the area of the square is S squared. Or if it was a semicircle, if this is a semicircle being built out, either you memorize the area of a semicircle, 1/2 pi S squared, or you learned it was half of a circle, so it's 1/2 of pi R squared, but we remember R is S over 2. So either one of these would be the area of this. So if the cross-sections were squares or they were semicircles, but here the cross-section is just whatever. And here's the general formula. This right here, this is my formula for volume when you are creating cross-sections. All right, this A of x stands for the area of one cross-section. So if it's a square, one cross-section is S squared. You put an S squared there. If it's a semicircle, you use either one of these versions. But sometimes, like this question here, they literally just give you the area of a cross-section. They tell you the area of a cross-section. It's not one of these shapes. We're not even telling you the shape. We're just telling you the cross-section is always, and you can see it's 1 over x plus 3. Look at, they tell you exactly, a of x is 1 over x plus 3. So we are going to use that. So it's the integral from 0 to 2. We're still adding it up from 0 to 2. And it's just 1 over x plus 3. Now, they didn't ask us for setup only. They wanted us to finish it. So let's take the antiderivative. This is perfectly du over u. If the bottom is u, the du would be 1. That's what we have. So it's ln of u. And then we're going to plug in the top and the bottom and subtract. So we plug in the top. Obviously that's a 5, but I don't feel like simplifying it. And then I plug in a 0. Don't feel like simplifying it. And there you go. That's my answer. Perfect. That's part B. Wow. All that is part B. I don't know why I'm forgetting to write that down today. All right. And now we're going to go to part C. So for part C, they don't want us to finish it. They want this setup only. And write but do not evaluate the integral expression that gives the volume of a solid generated when it's rotated about the line y equals 6. So here we're going to put the line y equals 6. And the first thing you have to think about is when we're rotating this, is there basically going to be any empty space? So when this rotates around, there's going to be empty space. So when I chop it up, it's going to be a washer. So the first thing I'm doing is setting up my washer. Pi outer radius squared minus inner radius squared dx. And I'll be adding them up from 0 to 2. Now I need my outer and inner radiuses. Well, all I'm going to do is draw them. The outer radius is always the furthest one. So the outer radius would be from here all the way down here. So I've now drawn my outer radius, and now the equation of my outer radius, the equation of the outer radius is just what's the top equation minus the bottom. So the top is 6 minus the bottom, and the bottom is g of x. I do not want to write all that out. If I wanted to write all that out, -2 plus, I'd have to put it in another set of parentheses. But it's already labeled as g of x, so I'm just going to call it g of x. And then my inner radius is right here, the closer one. And it's again top minus bottom, so it's 6 minus this whole equation, which I'd have to put in parentheses, but I'm just going to call this whole equation h of x. So it's 6 minus h of x. And like we've seen, you got to have parentheses because it's outer radius squared. So parentheses the square, and there you go. They didn't ask you to do anything else. They said set up only. We don't have a calculator, so we're done. Thank you so much. Bye.